Today we're going to finish the last piece we need for graphing absolute value equations. And just a quick reminder of what our original graph, y equals the absolute value of x, looks like. We had that vertex point, that anchor point, middle point, the point of the v, whatever you'd like to call it, is at 0, 0. Slope of the right side was 1. Reflect our points over, and get our other side. So this is our most basic graph. So far, we've multiplied absolute value by a number, which caused our graph to stretch, shrink. If we multiplied by a negative, it made our graph reflect. Last class, we did some adding and subtracting inside the absolute value bars, and we saw our graph move left and right. Now today, the last thing we need to do to transform our graph or change our graph, we are going to add and subtract again, but now it's going to be outside the absolute value bars. So the generic form is here off on the end. Notice the absolute value bars are closed around the x, and then the addition happens outside of the bars. So let's try this out. Let's go back to our tables, since we have no idea for sure what this graph is going to do. And let's continue our strategy. Let's start down at the positives. So inside the absolute value bars, I'm going to replace x with a 2, and then we have plus 1. Order of operations, I have to do the absolute value of 2 first, which is 2, and then I add my 1. So the first point we get is 2, 3. So 2, 1, 2, 3. Next, we put a 1 in for x. Absolute value of 1 is 1. 1 plus 1 is 2. 1, 2. We only have 2 points right now, so we're not sure what our v is looking like quite yet. So let's keep rolling. Put a 0 in for x. Absolute value of 0 is 0. 0 plus 1 is 1. So 0, 1. Now we have 3 points, but we still just have a straight line. Not real sure when our v is going to change directions. So let's move to the negatives. Negative 1 goes in for x. The absolute value of negative 1, remember, absolute value means a distance. So the absolute value of negative 1 is 1. 1 plus 1 is 2. So we get negative 1, 2. Now our graph's starting to turn the other way. Now we're starting to get that V shape. Just remember, guys, absolute value means the distance the number is from 0. It doesn't mean I just change its sign. Absolute value of positive 2 was 2, because positive 2 is 2 spaces from 0. Absolute value of positive 1 was 1, because 1 is 1 space from 0. The negative 1, its absolute value was also 1. So the end result of absolute value is always going to be positive. Put a negative 2 in now for x. Absolute value of negative 2 is 2. 2 plus 1 is 3. So negative 2, 1, 2, 3. Looks like we have a nice symmetric V shape, so let's forget about that last part of our table. We don't really need that. So the red graph is that original, just plain old y equals the absolute value of x. The slope of the red graph was 1, up 1, right 1. Now the slope of the purple graph is still just up 1, right 1. So my slope is still 1. So adding 1 didn't change my slope. My original vertex point was at 0, 0. Now that vertex point is up at 0, 1. So the whole graph just shifted up 1. So we moved up 1. So adding the 1 outside of the absolute value bars caused our graph to just move up 1. It didn't change my slope at all. It just changed everything up 1 is all that happened. So adding outside the absolute value bars caused our graph to move up. Let's see what happens now when we subtract a number, but again, we're staying outside of the absolute value bars. So here's the generic form. Notice again, the absolute value bars, they're closed around the x. The minus the number happens after the bars, outside of them. So once again, I'm not sure what this graph is going to look like. But what I do know is I did put an extra row in the table, so let's get rid of that row. Let's not do extra work today. I'm going to start at the positive end again. So in for x, we're going to put 2. Absolute value of 2 is 2, minus 1 is 1. So we get 2, 1 is our first ordered pair. 2, 1. Next in for x is 1. Absolute value of 1 is 1. 1 minus 1 is 0. Zero in for x. Absolute value of 0 is 0. 0 minus 1 is negative 1. Now here's where we have to be careful. I can get y values that are negative. Just because there's absolute value in an equation doesn't mean I cannot get negative results or negative y values. The absolute value itself, the absolute value of 0 was 0. The reason why our final result was negative was because we subtracted 1 after we took the absolute value. So again, we see absolute value of negative 1. Absolute value of negative 1 is 1 minus 1. We get 0. So negative 1, 0. And then negative 2 in for x. Absolute value of negative 2 is 2 minus 1. My y value is 1. Positive 1, there we go. So negative 2, 1. And we make our nice V shape. Just as a reference, I'm going to draw it on my sheet. You can draw it on yours if you'd like. Here's our original graph of just plain old y equals absolute value of x. There's the original. What did subtracting 1 do? Well, it didn't change our slope. Our slope is still just 1. What it did change, though, it did exactly what we thought. It made our graph, it moved down 1. So we have to be very careful. When we added and subtracted last class, it was inside of the absolute value bars. Inside of the absolute value bars, we moved our graph left and right. Now we're adding and subtracting outside of the absolute value bars. And when that happens, our graph moved up or down. So all in all, hopefully what we've learned is that adding and subtracting causes our graph to move or to shift. It might be left or right, it might be up or down. Adding and subtracting, though, does not change my slope at all. It does not cause my graph to reflect either. Adding and subtracting can just move or shift our graph. So we have all the different pieces that we need. Now I do want to take some time to go ahead and summarize everything that we've done down at the bottom of our sheet. And the first thing I want to do, and I apologize for this, but I copied and pasted this from another place. So what I want you to do is cross out the B. I'm going to cross out the B and cross out the C. I copied this from another place, and I want to make sure that we're using the same variables that you guys will see in some of your later math classes, like the class you'll take next year. So this should be an H, and this should be a K. Now I realize you probably don't have whiteout like I did on here, so just scratch yours out and put an H, and scratch yours out and put a K. If you want, I have whiteout. If you want to use whiteout and make that actual change on your packet later, you are more than welcome to do that. Just ask for the whiteout and you can make your change. I apologize for that, guys. That's totally my fault. So let's go from left to right. The first thing I see is a negative sign. We've looked at this negative sign the last few classes. If there's a negative sign in front of our absolute value bars, that's going to cause a graph. It's going to cause a reflection. And how some of you like to describe that is that it flips, and some of you like to say it's upside down. Now the A value itself, and actually we put the sign with it also, that's going to give us the slope on the right side of our graph. And that includes the sign. So if it's a negative, our slope's going to be negative. If it's positive, our slope's positive. Now, just looking at the actual number, the actual A value itself. If A itself if A is bigger than 1, we're going to stretch. And for some of you, you like to write that means it's skinnier, or some of you like to say narrow. Either way works. If our A is between 0 and 1, that's when we shrink. And some of you like to say that makes the graph wider. And a lot of you also like to say that it's flatter. So however you want to phrase that, these are your notes, so you put what works best for you. So the negative sign and that A piece, that's something we've worked on the last few classes. We've seen and talked about and summarized. Last class, the new part for us last class was adding and subtracting inside the absolute value bars. And I know for some of us, we just always want to go with our first instinct when we see that minus. When we see a minus sign, we think negative. And all the graphing we've done all year, when we've seen a negative, we've been thinking it's going to go left. But we saw it last class. We graphed it. We made a table, we graphed it. We saw that even though we were subtracting, we went to the right. And again, we made a table, we saw it. When we did addition, we saw our graph move left. This piece, I'll be very honest, the adding and subtracting inside the absolute value bars, that's probably where I see the most mistakes every year.
She was ready to come back today. She had some animal crackers left from first period.
Oh, I don't know where where'd my recording go?
You sure you don't want the rest of these? Okay.
Sorry for the interruption there, guys. If I'm adding or subtracting inside the absolute value bars, that's usually the place I see the most mistakes on quizzes and tests. It takes a lot of practice, and remember, we talked last class, we have to make sure we're practicing it the right way. Don't just go with your gut on this one. Double check your notes. Take a look. I'm subtracting, I move right. I'm adding, I move left. The last piece, the new part from today, we had the addition and subtraction outside the absolute value bars, and that does exactly what we think it should do. When we added a number, we move up. When we subtracted a number, we move down. So we have to be careful. Adding and subtracting inside the absolute value bars moves our graph horizontally left and right, and then adding and subtracting outside the bars does something totally different. It moves our graph vertically, which is up and down. So now today when you're doing your practice piece, have this in front of you. Whether you are able to have your sheet, or if you want to just rewind this video back and just pause it so this is up on your screen, that would be a fantastic idea. What I want you to do is go to the back side of your sheet where the practice piece is, and I want to do number 1 with you just to set the expectation. When you see your quiz next class, your quiz will count as part of your grade. And when you see your quiz, it's going to look just like this practice sheet. Now the problems, the questions themselves will be different, but the setup you will see will be the exact same. So there's no surprises tomorrow at all. So as we look at question number 1, I always like to start with looking at stretches and shrinks and reflections first. I like to look for that A value. And you might be thinking, wait, Miss Golly, there's not a number there. Well, if there's not a number there, we know we can always fill in with a 1. So that 1, stretch or shrink, well, it's not bigger than 1. It's not between 0 and 1. So stretch or shrink, there's none. Or you could put no there if you want to. It doesn't stretch or shrink, and not every graph will. So I wanted to make sure I reminded us of that because I know we've been doing a lot with stretches and shrinks. Not every graph will stretch or shrink. Some of them just simply have a 1 there. Since that 1 is positive, there's no reflection. We need a negative sign to reflect. So you might be thinking, oh, Miss Golly, then what's the point of even thinking about that 1? That 1 tells us the slope of our right side. So we'd have a 1, make it into a fraction, be 1 over 1. So the 1 would be up 1, and then we go right 1. So that takes care of the number in front of the absolute value bars. If there's not 1 there, write a 1. So the number in front of the bars takes care of those first 3 answer blanks. Then I look inside the absolute value bars and I see a minus. Now that's where you're going to want to go back to your notes and double check. Don't just go right away with your gut instinct, because with all the graphing stuff we've been doing, that initial instinct might not be right. When we see that minus there, I know, again, minus for us, we're thinking negative, and we think negative. All the graphing we've been doing, we think left. But we graphed it last class, and remember, it goes right. It goes right 1. Then the new piece for us today, we're adding outside the bars, and that goes exactly how we think it should. It goes up 2. So you might be thinking, okay, Miss Golly, so now we have all that stuff, so now how do we use it to actually graph? The left, right, up, down piece, that gives us our vertex, or that anchor point. That point where the V changes directions, the middle point of the V, however you want to describe that. So we always start at 0, 0. We're going to go right 1, and we're going to go up 2. That gives us our vertex point, that middle point of our graph. From that point then, I use my slope. Up 1, right 1. Up 1, right 1. Just do a couple points on each side. We don't have to get too carried away. Then if you need to, draw that imaginary axis of symmetry down the middle and reflect your points over. So this point is 1 away, so we need 1 away on the other side. This point is 2 away, so I need 2 away on the other side. And most of the practice you've been doing the last couple classes, you've figured out what works best for you to get that left-hand side of your graph. So again, your quiz next class, each question will look just like this. I essentially took this sheet and put different questions on it. Same format, same expectation. The only thing I do want to note before you continue with your practice is question number 6. Question number 6, you will have to go off your graph a little bit. I apologize. When I wrote the question, I liked the question, and then I didn't make a bigger graph for it. So I know I usually tell you don't go off your graph. You will have to go off your graph. Just a couple boxes is all. You'll have to go just a few more on the y-axis. So I do apologize for that, but that is a change you'll have to make on there. I'll make sure they all fit on your quiz though. I do have an answer key for you. Over on the table by the chalkboard. So the rest of the time is yours to practice. I will put this part up here as the end of the video, so if you just want to keep this paused up on your screen, so you don't have to flip back and forth on your sheet, that would be a great idea.